Hello everyone, welcome back to the Math UMS class this week. How did you do in the previous lesson? Did you enjoy the previous video? I have received some very nice comments from you and to be honest they motivated me a lot and I have tried my best to prepare for this lesson. I hope that this video won't disappoint you. At least it is as good as the previous ones. Okay, are you ready? Let's begin. First, let's see who's our guest today. Please make some noise for Nian the cat. Hi Nian the cat, welcome to the UMS Math class. Hello. Oh, so Sconby invited you. Thank you very much, Sconby, for inviting the cat to the class. I believe that he or she will help me a lot. Actually, I haven't known the gender of Nian the cat yet. Okay, so today we are gonna learn about regular polygon. Okay, let's see what do we have about regular polygon. A polygon is said to be regular if all sides are equal and all angles are equal. Quite straightforward, right? To create regular polygons, we use sticks of equal lengths and begin with a three-sided polygon. We all know that we cannot make any polygon from only two sides, so we need to begin with three-sided polygon. Now, can you picture it? A three-sided polygon, a regular three-sided polygon. It is nothing but the familiar equilateral triangle. I think that everybody knows about equilateral triangle, alright? All sides are equal, all angles are equal, and each of the angles measures 60 degrees. Very familiar. And the next polygon in line is the four-sided regular polygon. Again, picture it. Can you imagine how a four-sided regular polygon looks like? Again, it is still a familiar shape. It is a square. Everybody knows about square, right? All the properties. And if we add one more stick, then we will have a pentagon. Pentagon. And the pattern continues forever with as many sides and angles as we want to. There are many more in the regular polygon family, but we won't discuss about all of them, but instead we will examine thoroughly about the most common ones. Yes, I agree. First, we are gonna discuss about the perimeter and area of regular polygons. Very simple. The perimeter of regular n-gon is a times n, where a is the side length. Okay, we know that the perimeter is nothing but the sum of all sides of a polygon, right? And in regular polygon, all sides are equal, so we all need to take the product of the number of sides and the side of each length. In a triangle, we have the perimeter is equal to 3a. In a square, we have 4a. In a pentagon, 5a. And in a hexagon, it is 6a. Very simple. Now let's have some practice. Let me given the figure below, given that the perimeter of the square is 16 inches. What is the perimeter of the triangle? Okay, pause the video and try to find the answer yourself before I will show you the solution. Have you got it? Good. Here's the answer. First, we need to calculate the side length of the square. We take the perimeter, which is 16 inches, divided by 4 to get the answer of 4. Oh, I'm sorry. That would be 4 inches and 12 inches. Okay. Let's pause the video a bit. Oh yes, sorry for that inconvenience. I have fixed it. We take the perimeter of the square and then divide it by 4 to get 4 inches is the side length of the square. And it is also the side length of the equilateral triangle. So we can calculate the perimeter of it by take the side length multiplied by 3. So we have the perimeter of the equilateral triangle 12 inches. Okay, now everything is good. Have you mastered the perimeter of regular polygons? Alright, now we will discuss more about the area of regular polygons. When it comes to area, things are a little bit trickier because different regular polygons need different formulae for area. For all formulae, however, the side length is the only value needed. We only need to know the side length and then we can calculate the perimeter and the area of any polygon. Okay, we begin with a square because it is the easiest to calculate. If the side length is a, then the area of the square is a squared. Now, back to the three-sided polygon, which is the triangle. Now let's try to find the area for an equilateral triangle. We know in advance that in a triangle, S is equal to half of the product 8 times base. We know that the base is 8, so all we need to do is to find the height of an equilateral triangle. We can see that an equilateral triangle can be divided into two equal right triangles like this, with A is now the hypotenuse and a leg is A over 2. The height is the other leg of the right triangle. We apply the Pythagoras theorem to get h squared plus a over 2 all squared equals a squared. After some simple calculation, we have the answer. H is equal to a squared root of 3 divided by 2. So the height of the equilateral triangle is a square root of 3 divided by 2. Apply the formula for the area of the triangle. At S is equal to 1 over 2AH equals 1 over 2A times a square root of 3 divided by 2. And that should be a squared square root of 3 divided by 4. You should remember this formula because it is very important. We will apply this formula in the very next example. Calculate the area of an equilateral whose perimeter is 6 centimeters. The side length of the triangle is 6 divided by 3 and it is equal to 2 centimeters. Now apply the previous formula. We have the area of that triangle is S is equal to 2 squared square root of 3 divided by 4, and that can be simplified into square root of 3. Okay, have you mastered it? Now move on to the regular hexagon. It looks a little bit difficult, right? But if we use a trick, we can reduce this to a very simple problem. A regular hexagon can be broken into 6 identical equilateral triangles, like shown on the screen here, and this will help us calculate the area. Now first we will try to find the area of each triangle, which is already known. It is a square root of 3 divided by 4 because all 6 triangles are equilateral. So we'll take the product of that value to 6 and we will have the area of the regular hexagon. S is equal to 6 times a squared square root of 3 divided by 4, and it is 3 square root of 3 a squared divided by 2. Okay, remember this? If you feel that there are too many formulae to remember, so you can think of a hexagon as 6 identical equilateral triangles combined. So you have to remember the formula for the triangle only. Yes, the cat thinks the same. Here's a bit of practice. Given that the area of the square is 16 square centimeter, calculate the area of the hexagon. Again, we will divide the hexagon into 6 identical triangles. And now we calculate the square side, or the main diagonal of the hexagon. Can you see that? The main diagonal of the hexagon is equal to the side of the square, and that should be 6. The side of the hexagon is 6 divided by 2 equals 3. So we know that the area of the hexagon is 3 square root of 3 times 3 squared divided by 2, and that should be 27 square root of 3 divided by 2. So far so good. Are you still following? Feeling dizzy yet? But as I have mentioned before, for other types of polygon, much more complicated formulae are needed. So we don't concern those formula, those kind of polygons for the time being. We just focus on what we have learned and what I have shown you in this lesson. But prepare yourself for the next part. The interior angles. We know that all angles in a regular polygon are equal, right? So here are the interior angles. They are all equal. And each type of regular polygons has a fixed measure for its angles. Now we will try to find the measure. Okay, show me, please. Here the cat. We all know that the angles in a square or an equilateral triangle, we know the measure, right? How about other regular polygons? I will use the hexagon as a visual example and try to explain the solution in the general form for n-gon. From the center of a regular n-gon, we draw segments connecting it with the vertices. I will use the hexagon as the example here. We take the center and we draw the segments connecting the center with the vertices. By doing that, we will have n equal triangles. In this case, 6 equal triangles. Sum of all angles in each triangle is always 180 degrees, right? It holds in any circumstances. The sum of all angles in each triangle is always 180 degrees. And look at the center, we have n equal angles in the center, right? And we know that the sum of all angles is the number of angles in a triangle, which is 180 degrees multiplied by the number of triangles. So the sum of all angles is n times 180 degrees. Note that this sum includes both the angles in the corner and the angles in the center. In a hexagon, it is 6 times 180 equals 1080 degrees. Now we will find the sum of all interior angles. In order to find the sum of all interior angles, we will subtract the angles in the center. Can you see that? If we subtract the angles in the center, now the sum of remaining angles is the sum of the interior angles. Note that the angles in the center make a full turn. See that? That makes a full turn. So the sum of all angles in the corner is 363. 360. Sorry. Hence, the sum of all interior angles is n times 180 degrees minus 360 degrees. And we know that all the interior angles are equal to each other, and we have n of them. So the measure of an interior angle of an angon is n times 180 degrees minus 360 degrees, all divided by n. We take the sum of all n interior angles divided by the number of angles, which is n. In a hexagon, it is 1080 degrees minus 360 degrees, all divided by 6, and the answer is 120 degrees. You can easily confirm that result by seeing that each interior angle in the regular hexagon is equal to two angles in an equilateral triangle, right? And it is 60 plus 60, and that makes 112. 120, sorry. Remember this formula. We're gonna have some practice. Remember this, please. And here's the practice question. Calculate the interior angles of a regular octagon. Remember what an octagon is? It is 8-sided polygon, and it is regular in this case. And as usual, we divide it into triangles. We know that sum of all interior angles is calculated as follows. 8 times 180 degrees minus 360 degrees equals 1080 degrees. So the interior angle of a regular octagon is 180 degrees divided by 8 to have 135 degrees. Have you mastered the formula? Okay. That was a long journey, wasn't it? With so many formulae to remember. But don't worry, they are very um, like helpful in the practical situations. So by doing homework or practicing in the real situations, you will remember it naturally. Okay, and that is the end of the lesson. Here the homework. Here's the homework. Review the lesson, memorize the formula for perimeter areas of regular polygon. Practice calculating the area, perimeter, and interior angles of regular polygons. And complete the online quiz as usual. Okay, thank you very much for attending the class. And also thank you very much, Nian the cat, for helping me in this lesson. Okay. Okay, do you want to invite a friend? Okay, that is welcome. If you want to invite any friend, you can comment in the section below, and I will try to invite him or her to the lesson next week. Okay, that's it for now. Goodbye, everyone, and see you in the next lesson. Goodbye.